Okay, so this time our topic is very important, no? Network security and secure system architecture. No, uh, network security and secure system architecture are essential components of a modern cybersecurity, no, designed to protect digital assets from unauthorized access, so cyber threats and data breaches. Network security focuses on safeguarding the integrity, confidentiality, and availability of data as it moves across networks, while secure system architecture involves designing and implementing systems that are resilient against cyber threats. Together, these elements form the foundation of a robust cybersecurity framework for organizations. And to give us more details about the topic, let us all welcome our presenter. Go ahead.
Hi, good evening, everyone. My name is Morse Siminea, and I'm reporting this Module 4 Network Security and Secure System Architecture. So let's proceed. First, the network security fundamentals, firewalls, IDS, IPS, and VPNs. Firewalls are the gatekeepers of network security. They monitor and control incoming and outgoing network traffic based on predetermined securities rules. Firewalls and can be implemented as hardware, software, or a combination of both. Their main objective is to establish a barrier between a trusted internal network and untrusted external networks, like the internet. And there are different types of firewalls, such as filtering firewalls. And the second one is stateful inspection firewalls. Third is proxy firewalls. And after this network security fundamentals for firewall IDS, IPS, I will present a video to explain further for this topic. And then intrusion detection system, that's the IDS. And the IPS is the intrusion prevention systems. So these two are critical for monitoring and protecting networks from malicious activities. And the IDS monitors network traffic for suspicious activities and sends alerts when such activities is detected. Think of IDS as a security camera that detects potential intruders. And there's two. The one is signature-based IDS, and the second one is the anomaly-based IDS. And then the IPS is similar to IDS but takes proactive action to prevent threats, while IDS alerts, IPS can block or prevent threats in real time. So there's two IPS. The one is network-based IPS. The second one is the host-based IPS or HIPS. NIPS and HIPS. Okay, and the last one is the VPN, the virtual private network. So this VPN creates secure connection over public networks, allowing users to send and receive data as in their devices were directly connected to a private network. This ensures confidentiality, integrity, and authenticity of the data being transmitted. And there's different kinds of VPN. One is your remote access VPN, site-to-site VPN, IPsec or Internet Protocol Security. The second one is, or the fourth one is the secure sockets layer or transfer layer security. And the last one is the open VPN. So let's proceed to the video I have here. Kita po ba?
Yes.
Kita. Okay, thank you.
Security components which are used in almost all the company's infrastructure setup, that is firewall, IPS and IDS. IDS means intrusion detection system and IPS means intrusion prevention system. In fact, many times network and security administrators also tend to face challenge when asked what are the primary differentiators between firewall, IPS and IDS. So let's start. The main difference being that firewall is a security device which filters the incoming and outgoing traffic based on some predefined rule set which is configured by the security administrator. In contrast, an IPS is responsible for inspecting, detecting it, classifying, and then stopping the malicious traffic from attack. IDS is also a close relative of IPS. However, ITS will not block the traffic unlike IPS. It will monitor the traffic for malicious activity and only sends the alert on its detection. This alert is generally sent either to the network or security administrator or else to a SIEM system. A firewall allows traffic based on a set of rules configured. It relies on the IP source, IP destination addresses, and the ports. A firewall can deny any traffic that does not meet the specific criteria. IPS inspects real-time traffic and looks for the traffic pattern and signatures. Based on its detection, it will prevent the attack. IDS will also detect the anomaly with same approach. However, it will send the alert and not disrupt the traffic. Here it is important to note that IPS can sometimes give false positive results and block a legitimate traffic. Hence, many administrators or companies prefer to have IDS in the setup and not IPS, since they don't want the genuine traffic to be blocked, which can be a bad customer experience. In terms of configuration mode, firewall is configured in inline layer 3 mode or transparent mode. In layer 3 mode, it is required to have separate segments carved out, and the network, or to be precise, architectural changes are required. However, transparent mode is simple to implement with no significant changes in network, albeit there are some associated limitations in transparent mode. Talking about IPS, it always has to be in inline mode, while IDS can be either in inline mode or the host, that is spam mode. When it comes to placement of these security devices, firewall is placed at the perimeter or edge of the network, which is much closer to the internet entry exit points. IPS also should preferably be provisioned after the firewall, and then IDS can be positioned in non-inline mode, that is also called spam mode. A very interesting distinction of firewall from other two elements is that firewall doesn't analyze traffic patterns, while IPS and IDS have the key functionality to analyze the traffic flow or patterns. As we discussed earlier, firewall is always first line of defense. IPS should be placed after firewall. When it comes to action taken on detection of unauthorized traffic, firewall simply blocks the traffic from entering, and same is what IPS will do. However, IDS will not prevent the traffic from entering the network, rather just sends alert to the concerned. And same is the case of IDS, which should analyze the traffic after the firewall. When it comes to action taken on detection of unauthorized traffic, firewall simply blocks the traffic from entering, and same is what IPS will do. However, IDS will not prevent the traffic from entering the network, rather just sends alert to the concerned. Now that we have high-level understanding of the three essential security components, let's reiterate the key features and functionality of each one. Firewall related terms are stateful firewall filtering and inspection. It permits and blocks traffic based on ports and protocol rules. IPS related terms are anomaly detection, signature detection, zero-day attacks, blocking the attack. IDS related terms are anomaly detection, signature detection, zero-day attacks, monitoring, and alarm. That's it from the comparison of security components, that is firewall, IPS, and IDS.
Ayun, natapos na rin. So, let's proceed na sa reporting. So, ang next natin ay ito, ang secure network design or zero trust depends in depth. So, ano ba yung zero trust? It's a security model that operates on the principle or never trust, always verify. So, it assumes that threats can come from both outside and inside the network. And therefore, no entity, user, or device should be trusted by default. Instead, every access request must be authenticated, authorized, and continuously validated. So ano ba yung components ng Zero Trust? So ito siya, which is strong authentication, least privilege access, micro-segmentation, continuous monitoring. So ito, depends in depth. So depends in depth is a layered security strategy that employs multiple security measures to protect an organization's asset. The idea is that if one layer of defense is breached, additional layer will still provide protection. So ito yung elements or key elements of defense in depth. Includes perimeter security, endpoint security, network security, application security, data security, user training. And then ito yung conclusion. By combining zero trust and defense in depth strategies, organization can create a robust security posture that addresses both external and internal threats. So meron tayong sample video dyan. And ito.
Network access, or ZTNA, is a category of technologies that provide secure, remote access to application and services. Unlike VPNs, ZTNA provides secure access on a per application basis, automatically setting up and tearing down tunnels as necessary. But to understand ZTNA, it's important to know the model and frameworks it's based off of. You see, ZTNA is a component or subgroup of the Zero Trust security model. This model provides a philosophy on how we should approach network security. This foundation is important in understanding the components and methodologies in how we accomplish ZTNA. In this video, we'll take a look at the Zero Trust security model and the foundations it's based on. We'll also take a deep dive into Zero Trust network access and look at the pillars and components that make up this architecture. Lastly, we'll take a look at some practical examples on how this is being used in the real world and the vendors who are accomplishing it. To understand ZTNA, we first need to understand the Zero Trust security model. This model or framework adheres to the philosophy that no one outside or inside the network is to be trusted unless their identification has been thoroughly checked. The assumption is that anyone can be compromised, so it doesn't matter if you're on the same network or across a globe, everyone must be verified. In other words, access to application and resources are not accepted based on location. In fact, location is irrelevant. This means that users inside and outside the network are not to be trusted by default. Simply put, traditional IT network security trusts anyone inside a network once they've been verified. In the Zero Trust security model, trust is never assumed by default. Instead, users, regardless of location, are to be verified and given only the minimum amount of access that they need. This means that a user request to application A will be verified and authorized only for that specific application. Access to other applications will not be granted on the notion that they've been verified once before. Instead, each application service is verified independently. Verification is accomplished in different ways depending on the implementation, but at a minimum, it includes the following three pillars: identity, context, and security posture. Identity involves user identification, authentication, and authorization. In other words, who are you? Are you who you claim to be? And are you authorized for that resource? Identification of said user should typically include a second or multi-factor authentication. Context is about how the user is trying to access the resource. This pillar is based on the least privileged security model, where users are only granted the least possible amount of access that they need. In Zero Trust, this concept is actually taken a bit further, where applications are hidden from the user without proper access. Only users who are authorized for a particular resource will even see that the application is available. The last pillar in verification is security posture. This third pillar focuses on the device the user is connecting in on. If you verified who you say you are, and you should be allowed access to the resource, the next question is your machine secure? Security posture may encompass several different checks on the user machine to make sure that the device is compliant. This could be as simple as verifying that a software like antivirus is running, or this could be extended to make sure that several different conditions are met before granting access. An important thing to note is that Zero Trust never stops on just a verification. Once a user has been granted access, Zero Trust requires continuous monitoring and validation. Any changes to the identity, context, or security posture will be reevaluated and revoked as necessary. Zero Trust security is a model and a mindset about how to approach network security. However, it's not a technology. Zero Trust Network Access is a technology by which the principles of Zero Trust can be used to secure access to application and resources. The core piece of technology that enables the Zero Trust principles is called the Trust Broker. This piece of technology sits between the user and the application. The Trust Broker provides logical access boundaries and adheres to the principles of Zero Trust. This means that the Trust Broker is responsible for the verification of the identity, context, and security posture. Once verified, a connection is established per application between the user and the specific application the user is requesting. It will continue to monitor for changes to the identity, context, and security posture for the life cycle of the session. In practical terms, the Trust Broker can be a network device or a cloud provider depending on where the application sits and your implementation of Zero Trust Network Access. If your application and resources are accessed through SASE or SSE, the Trust Broker is the cloud provider itself. Example of these would include Zscaler, Palo Alto Prisma Access, Cato Networks, and Cloudflare, to name a few. If your application and services are hosted on-premise, for example, in the data center or an HQ location, the Trust Broker could be a network equipment like a firewall. Example of these would include Fortinet, Palo Alto, Checkpoint, and of course many others. The important thing to note here is that the Trust Broker is usually not a single device, but a decentralized solution of various technologies that make up the control and data plane. The control plane controls the management, intelligence, and monitoring of the ZTNA policies. The data plane handles the enforcement and usually sets up the connection between user and application. The makeup of ZTNA will vary by vendor, so it's not as important to know the design as much as it is to know that the technology can handle the principles of Zero Trust one way or another. In fact, from a technology perspective, there's many different ways to accomplish ZTNA, and rarely is it achieved the same from vendor to vendor. In one of my previous videos, I described in detail how to accomplish Zero Trust security using SDP, or Software Defined Perimeter. And while SDP is one way, it's certainly not the only way. For more details on how SDP works, take a look at the video which was recommended by the Cybersecurity Cloud Alliance as a must watch for SDP in my previous releases. Let's wrap up by taking a quick look at how ZTNA all comes together. A user needs to access a corporate application and logs into their IDM solution using multi-factor authentication. The principles of Zero Trust provide the user with visibility only to the applications that they are specifically authorized for. When the user attempts to access the resource, the verification, context, and security posture of the user is verified to that application. If successful, the Trust Broker sets up a tunnel between the user and the application that they requested. Once connected, the verification process is continuously monitoring for any changes to the identity, context, or security posture. If the user needs to access a second application, the entire process is done again, with a new verification process and tunnel establishing for the second application. Remember, with ZTNA, location is irrelevant. The user can be right next to the machine or 1,000 miles away. As it implies, Zero Trust is about trusting no one but verifying everything. This wraps up another video from the CISO perspective, and I hope you found it informative. As always, please take a moment to hit like down below.
Ayun, natapos na rin yung pang second natin. So, let's proceed na sa pang third na lesson, which is wireless network security, WPA3, MAC filtering, rogue AP detection. So, yung WPA3, ito po yung Wi-Fi Protected Access Tree. It's the latest security protocol designed to safeguard Wi-Fi networks. It offers several enhancements over its predecessor, WPA2, to provide stronger security and better protection against attacks. So, yung key feature ng WPA3, Ito yung meron siyang strong encryption, forward secrecy, simplified security for IoT devices, and enhanced protection for public networks. So ano ba yung MAC filtering? Ito yung security features that allows network administrators to control which devices can connect to the network based on their unique MAC addresses. Key aspect of MAC filtering include access control, granular control, configuration. Ayan. So rogue AP detection are unauthorized wireless devices connected to a network without the knowledge of the network administrator. Detecting and mitigating rogue APs is crucial for maintaining network securities. Key aspects of rogue AP detection is identification, impact, and detections method. So ito yung pinakabuod niya. By implementing this wireless network security measure, you can significantly enhance security and integrity of your network. So let's proceed sa video para ma-explain niya mabuti.
Hello everyone. In this video, we're going to talk about the different wireless security methods and protocols that are used in wireless networks. Now, most of us have connected to a Wi-Fi network with our laptop, tablet, or even our smartphone. And to join that network with our device, you had to select the network name and you had to supply a password. Now, Wi-Fi networks can be just open with no password required. So that means that anybody can join it. However, in the majority of cases, Wi-Fi networks will be secure and will require a password. Now, there are several different protocols that are used for securing a Wi-Fi network. So let's start with a secure protocol called WEP. WEP, or Wired Equivalent Privacy, was developed in 1999, and it's the earliest security protocol that was used for wireless networks. And also, as its name implies, it's meant to supply the same security to wireless networks as it did for wired networks. However, this turned out not to be the case, because after a time, it was found out that the 40-bit encryption key that WEP used was vulnerable and not secure, and therefore it was easily hackable. So that's why today WEP is no longer used, and modern Wi-Fi routers won't even have it as an option anymore. So a better security protocol was needed for wireless networks. And that brings us to WPA. WPA, or Wi-Fi Protected Access, is another wireless security protocol that was developed to solve the problems of WEP. WPA is far better than WEP, and this is because it uses a stronger encryption method called TKIP, which stands for Temporal Key Integrity Protocol. And TKIP dynamically changes its keys as it's being used, and this ensures data integrity. But even though WPA is more secure than WEP, even today WPA is outdated because TKIP did have some vulnerabilities. And that brings us to WPA2. WPA2 was developed to provide even stronger security than WPA, and it does this by requiring the use of a stronger encryption method. While WPA uses TKIP for encryption, which is known to have some limitations, WPA2 uses AES, which stands for Advanced Encryption Standard. AES uses a symmetric encryption algorithm which makes it strong enough to resist a brute force attack. In fact, AES is so secure that the US federal government has adopted it and is now using it to encrypt sensitive government data. Now, when you log into the Wi-Fi router's configuration page and you go into the Wi-Fi security section, this is where you would find the different security protocols that you can choose from to protect your Wi-Fi network. So here is an example from an older Linksys router. And here you can see the WEP, WPA, and WPA2 protocols that we discussed. Now, as I said, this router is a few years old, and it still has WEP as an option. However, newer routers, like this one here, won't even have WEP as an option, because WEP is weak and outdated and is no longer used. And thank God for that, because it was garbage. Now you will also notice that on both of these routers, there's an option that has both WPA and WPA2. And this is a mixed security option. This option enables WPA and WPA2 at the same time. So it'll use both TKIP and AES security. Now the reason for this option is for compatibility purposes, because some older devices like prior to 2006 may not be compatible with using AES encryption that's used with WPA2. And so these older devices will connect to the older WPA protocol, but at the same time modern devices will connect to WPA2. Now some people might ask, why not just choose the mixed option all the time, since it's the most compatible with all devices? Well, you can do this, but the problem is that in addition to using AES, it's also using TKIP. And since TKIP is not as strong as AES, you're leaving your network more vulnerable to a breach. However, if all of your devices are modern, then the best option is to choose WPA2, which only uses AES. Now, the next generation of wireless security is WPA3. WPA3 was introduced in 2018, and according to the official Wi-Fi website, wifi.org, WPA3 provides cutting-edge security protocols to the market. It adds new features to simplify Wi-Fi security and enable more robust authentication. And it will receive increased protections from password guessing attempts. Now, WPA3 won't be available on every Wi-Fi router that you purchase today, because it was just introduced last year. However, you will start to see it more and more on Wi-Fi products in the next few months. Now, so far we discussed a few password-protected security protocols, but there is another wireless security method that doesn't require you to type in a password, and this method is called WPS. WPS stands for Wi-Fi Protected Setup, and WPS was designed for people who know little about wireless networks to make it as easy as possible for their devices to join a wireless network. So here is a WPS configuration page for our router, and there are a couple of different methods that are used with WPS, but by far the most common method is the push button method. So with this method, you would just press a couple of buttons and then you'll be connected. So for example, most routers today will have a physical WPS button that you can press. And a lot of Wi-Fi printers will also have a software or physical WPS button. So let's say you wanted to connect this wireless printer to your Wi-Fi network. So you would press the WPS button on your Wi-Fi router, and within 2 minutes you would press the WPS button on your printer. And then your printer would connect to the Wi-Fi router in a few seconds. And that's really as simple as it gets. And you can also use method 2 if you want, if your client has a WPS PIN number. So you would just enter that PIN number into the field below, and within a few seconds, it'll connect. So as stated before, WPS is the easiest way to join a wireless network, and a lot of manufacturers have built their wireless products with WPS. And this is to make it as simple as possible for their customers to join their device to a wireless network. Now there's one more method we need to talk about, and this is called the access control, or in some routers it's called the MAC filter. And with this option you can either allow or block devices from joining your network. Every network adapter has a MAC address. A MAC address is a hexadecimal number that uniquely identifies each device on a network. And with access control, you can either allow or block access by using the device's MAC address. When a device is blocked, it would only be able to get an IP address from your router, but it won't be able to communicate with any other device. And it would not be able to connect to the internet. So the access control is just an extra layer of security that's in addition to your Wi-Fi password. and the access control is also for wired devices.
So, yun. Ngayon ko lang din nalaman yung WPS button sa video na to. So, let's proceed na sa pang-apat. At yung
Zero
last.
Trust Network Access, or ZTNA.
Sorry. So, ayan. So, yung last natin is for secure software development and code review SDLC or DevSecOps. So, yung SDLC is Secure Software Development Lifecycle. Is a constructed process that guides the development of software from inception to deployment and maintenance, incorporating security into each phase of the SDLC ensures that security is not an afterthought but an integral part of the development process. So meron siyang phases. Una is planning and analysis, design, implementation or coding, testing, deployment, and maintenance. And then yung DevSecOps is an extension of DevOps approach that integrates security practices into every phase of the software development lifecycle. It emphasizes collaboration between development, security, and operations teams to ensure that security is a shared responsibility. So yung key principles of DevSecOps is security as code, continuous integration and continuous delivery, CI/CD, collaboration, automation, monitoring, and feedback. And then yung last code review is a critical process in secure software development. It involves the systematic examination of codes by peers to identify and fix security vulnerabilities, improve code quality, and ensure adherence to coding standards. So ano ba yung benefits niya? Early detection of bugs, knowledge sharing, improve code quality, and then compliance. So ito na yung pinakabuod niya, which is by integrating secure software development practices, DevSecOps principles, and through codes reviews, organization can build robust and secure software that withstands evolving threats. So, yung last sample video natin, ito na.
Common DevOps flow, where things are streamlined, everything is automated and fast. So developers check in the code and an application delivery pipeline starts. The changes are tested with automated tests. A new version is built and deployed to the test environment, where more automated tests will run, and when everything is fine, a green light is given to the new version to be released. So this super optimized and automated flow makes application delivery fast without manual effort from developers or testers, etc. Great. And the new version of the application is ready to be released in production. Well, not really, because what about security? If your application is an online banking app or a social media platform that millions of people use, or an e-shop with credit card information and other sensitive personal data, you want to make sure that there are no security holes in your application, because getting hacked and leaking sensitive data of your users may be detrimental to your business. So before deploying it to the production, the security team must test the new version for any vulnerabilities and other security issues. What if the developers used a new library that has some vulnerabilities? What if it has some special licensing requirements? What if passwords are exposed? What if container image has security issues? What if the Kubernetes components for the application are misconfigured? And of course, this could all be things that developers themselves aren't even aware of. So the security team will run tests and analyze the code changes and look for any security issues in the application. And this may take hours or days, or if you have a complex application, maybe even weeks. The security team may find thousands of vulnerabilities and issues and send them to developers to fix in that new version. However, in the meantime, because of the efficient DevOps cycle, a couple of new versions have been created, which are all waiting now in the queue for the security audit. So you see the problem here. You have this super optimized DevOps process that you built and are proud of, but right before the release, the security checks and audit blocks the whole process, delaying the release for weeks. Now, why does security audit take so long? To understand why it's a bottleneck in the process, think about how applications have evolved over the last years. We have microservices now instead of one monolith application, and they expose APIs to communicate, which means much more attack surface. On top of that, we have tons of services which microservices use, like databases, message brokers, service mesh applications, etc. So even more applications and more attack surface. Now these may all run in containers, which is yet another layer where security issues may arise. And all these may run on a cloud platform, maybe on a Kubernetes cluster. So you see that you have many layers of infrastructure and application and many components which need securing. And the security teams themselves need to also learn and understand all these platforms and technologies to be able to identify the issues. Another issue they have is that many security tools that security professionals use and are experienced in were developed way before Kubernetes or microservices. So they need to now find or create themselves tools for working with this modern application setup. And all that, of course, complicates the job of security professionals and creates this bottleneck in the application delivery process, slowing down the DevOps cycle. So how to fix the problem? The answer is by integrating security in the DevOps, or in other words, shifting security to the left. So instead of thinking about security after a new feature is developed and tested, right before releasing it and solving them in chunks, start thinking about security right at the beginning and solve it right away as soon as security issues appear. So how would that work in practice? And how can security be infused or integrated in this DevOps process instead of being a separate step here? Well, first of all, security becomes a developer responsibility too, instead of just being a responsibility of dedicated professionals. And the security team itself becomes more of a facilitator and advisor to developers and operations teams, helping them understand and manage security, rather than being like an external police that blocks the development speed. So the security team will create security policies, then they will create or select proper automation tools and platforms for detecting and identifying any security issues and vulnerabilities. And this could be security scans, code quality checks, automated security tests of the application, etc. And they will then train and teach developers and operations team how to interpret the output of these tools so that they can identify and fix the issues themselves. And one of the great security tools for the modern DevOps is K10, which is a sponsor of this video. K10 is a data management platform and actually recognized as the Kubernetes backup leader. As I mentioned, with new technologies like Kubernetes, new solutions are needed for data protection. And K10 just released a new ransomware protection solution for Kubernetes by supporting immutable backups. So with K10, you can automate your backups easily and securely by defining backup policies, which also helps in adhering to the compliance rules. On top of that, K10 integrates with all major cloud platforms, so you can manage and secure your data across platforms. So all of these security tools and platforms will be integrated in this CI/CD pipeline, and on every push to a feature branch or master branch, these tools will run and developers will get automated output on their application security status and what issues and vulnerabilities need to be fixed. If there are no security issues, the pipeline will deploy and release the application. So the manual work of security professionals will be automated and integrated into the application delivery pipeline, making the release process much faster. Apart from the speed itself, also note that having security checks later in the process increases the risk of security issues sliding into the production, and fixing security issues in production is much more expensive. On the other hand, identifying them and fixing them in the feature branch is much more efficient because of the short feedback cycle. Right after commit and push, the developer will know the security issue they caused right away and can fix it faster without a context switch. So overall, the DevSecOps process makes the whole application delivery fast again by reducing the feedback cycle on any security issues and by infusing the security checks throughout the pipeline instead of having it as a big task right before the release. Now, I hope I could make it clear for you what DevSecOps.
Yun po. So, yun na po yung workflow. And done na po siya. Sana may natutunan kayo sa mga sample videos. Pasensya na kung medyo maikli yung explanation. So, masama lang po yung pakiramdam. So, yun lang po. Thank you, classmate and prof.
Okay, so again, network security, protecting data in transit is the most important things that we need to look into secure. Network security involves the protection of data, devices, and system connected to a network. As our presenter mentioned, it includes measures such as firewalls, intrusion detection and prevention system, or the IDS, IPS, and virtual private network, or the VPNs, to prevent unauthorized access and cyber attacks. Organizations implement network security to ensure secure communication channels, protect sensitive information from interception, and prevent malware from spreading across system. The key threats to information security or to the network security is that there are several threats pose risk to network security, including the malware, phishing attacks, denial of service attacks, or the DOS attacks, and man-in-the-middle attacks. So cyber criminals often exploit vulnerabilities in network configurations, unpatched systems, or weak authentication protocols. Ransomware attacks, which encrypt data and demand payment for decryption, have become a significant threat to business, making network security to priority. Secure system architecture, building a strong cybersecurity framework is also another consideration, because secure system architecture refers to the design and implementation of IT infrastructure with security principles embedded from the ground up. A well-designed system incorporates least privileged access, defense in depth, and zero trust security models. By ensuring that security is a fundamental aspect of the architecture, organizations can mitigate risk and minimize potential attack surfaces. So what will be the principle of secure system architecture? A secure system architecture follows key principles such as confidentiality, integrity, and availability. So like CIA triad, systems should be designed with multi-layered security controls, ensuring that even one secure measure fails, additional defenses remain in place. So encryption, authentication mechanism, and secure software development practices are also crucial to protecting sensitive data and preventing unauthorized access. So what will be the role of encryption and authentication? Siyempre, encryption ensures that data remains unreadable to unauthorized user, both in transit and at rest. So secure communication protocols like TLS, SSL protect data exchange over the internet, while multi-factor authentication enhances identity verification, reducing the risk of credential-based attacks. these measures play a vital role in securing network traffic, databases, and of course, right now, the cloud environments. Now, so what will be the emerging technologies in network security and system architecture? I believe, no, with the rise of cloud computing, IoT or Internet of Things, and artificial intelligence, new challenges and solutions are emerging in network security and secure system architecture. So zero trust architecture or the CTA is becoming a standard approach, syempre requiring strict identify or requiring strict identity verification for access requests. No, artificial intelligence and machine learning are also being integrated into security system to detect and mitigate threats in real time. So to cut in short, this topic or the need, no, for proactive security measures. No, as cyber threats evolves, organizations must adapt proactive security measures by implementing robust network security strategies and secure system architecture. How will we be able to do that? Regular security assessment, patch management, and incident response planning are critical in maintaining a strong defense against cyber attacks. Through prioritizing security in both network and system design, our business or our agency or organization can protect sensitive information, maintain trust, and ensure compliance with cybersecurity regulations. Okay?